Now, we're going to talk about statistics. Well, this is a statistics class. The very first question that you should be asking is, what is statistics? What is statistics? Okay, well, what is a statistics? So these are the answers that I have from you, the data, the analysis of data, sorting and analyzing the data to find pattern, make predictions, and so on. So when you're defining statistics, we are saying that, hey, statistics is a branch of math. It is a branch of math that follows some important steps. The very first step is by asking a question. So in statistics, you always come up with a question or somebody give you the question. Ask a question. What is the average housing prices in Bay Area? Okay. What's the average GPA of students sitting in this class? Come up with a question or somebody gives you the question. After asking the question, well, I need to have some data to be able to answer that question, am I right? Well, I need to identify the population, the target, and then collect the data. Collect data by identifying the population. Okay. I have the question, what's the average GPA of De Anza College students? What's the average GPA of Stanford University students? I found the target population and I start taking random samples and collect the data. Okay, I have a bunch of numbers. I have a bunch of data. What should I do? I'm interested in visualizing the data. Visualizing the data helps you to find outliers and find the pattern in the data. So in the third step, we graph the data. Visualize the data. I expect you to ask, well, how do I visualize the data? Sometimes you have finite numbers of data. For example, I just want to know what is the average GPA of students sitting in my class. And I have, for example, 45 students. I have finite numbers of data. Well, I start using my whiteboard and a marker and graph the data. But if you have more data, we use softwares like Excel, like Python, like SPSS, SAS, and so on. That's how we visualize the data. Again, it helps us to identify outliers and find patterns. Okay. After visualizing the data, I'm interested in assigning some numerical characteristics to the data that I collected. Well, in the next step, I want to know what is the average, what is the exact number. I try to analyze the data. What do I mean by that? I try to find the center of the data. I try to understand the variability in my data. Find the center and variability. These are the things that we're going to learn in this course. Okay, so far we have descriptive part of statistics. Okay, how do I make predictions? How do I generalize this information to some future data? Well, the last step, which is very important and part of inferential statistics, is making predictions, making inferences, make prediction about future data or the data that you don't already have or the population itself. So if somebody asks you what is statistics, you say that statistics, first of all, it's a science. It's a branch of math that follows these important steps. The very first step, ask a question. Second step, collect data. Third step, visualize the data. Fourth, analyze the data. And the fifth step is making predictions or making inferences. Okay, now that we know what statistics is, we're interested in understanding some basic terminologies. When we're talking about statistics, the very important essence of statistics are the data itself. So if I ask you to define data, definition of data, you say that, hey, data is the collection of, for example, measurements, the collection of counts. Data is the collection of measurements or counts and so on. So when you're talking about the data, we're talking about a huge collection of measurements or counts or whatever you have. Your data are already here. When it comes to data, we can talk about either the population or we can talk about smaller sub-collection of populations. So, definition of population. There is an important keywords that we need to focus when it comes to statistics. When I talk about population, I talk about every, all, any. So these are the keywords. The collection that includes all, every, any data is called the population. Guys, it's important. When you read a paper, when you read an example, when you read the book or study for your exam, to identify the population, you need to have one of these keywords. All data, all measurements, all counts, every measurement, every count, any measurement, any count, it refers to the population. Remember that. When we are working with populations, since we have to collect data from every member in that population, it usually takes time, takes energy, takes a lot of resources. That's why we try to avoid working with populations. So let me write a note here for you. Collecting data from a population usually takes time, money, resources, and so on. That's why we try to avoid working with population. If we can work with a population, with every measurement, with every count, of course, we're going to have a very accurate collection. If not, well, we have to work with sub-collections of populations, which we call samples. Definition of a sample. A sub-collection or subset of a population is called a sample. Okay. Well, I expect you to ask, hey, professor, for population, you said we have some keywords like all, like every, like any. Do I have any keyword identifying a sample? To identify a sample, you look for keywords like survey. So if you see keyword like survey or random collection, random selection, it means that it all refers back to the sample itself. So survey, random collection, random sample, they are all about sample itself. In math, they use Venn diagram to distinguish between a population and a sample. They say that, hey, for a population, you're going to use this big circle, population. And then there are some small circles inside the population that we call sample. Sample 1, sample 2, sample 3, and so on. One population, but many random samples taken from that population. So in this example, identify data set. In a recent survey, 614 small business owners in the United States were asked whether they thought their company's Facebook presence was valuable or not. 258 of 614 respondents said yes. What is the population and what is the sample? So our goal is to identify the population and the sample here. So what do we have here? We have 614 small business owners. Guys, be careful. 614. We have a keyword, survey. 614 small business owners. So is it a population or is it the sample? Keywords, survey is sample. So you have a sample of 614 small business owners in the United States. The population is all small business owners. How many? I have no idea. I don't know the count. They didn't have time. They didn't have money. They didn't have enough resources to go and ask every small business owners in the United States. What they did instead, they took a small sample. This sample is including 614 small business owners in the United States. So here you have your sample. So this is your sample. All right. The confusing part is the number 258. I expect you to ask, so what is 258 then? This is your sample. In this sample, this is your sample. Some said yes. Some said no. Some said we don't know, we don't care. Don't know, don't care. This is your sample. In your sample, in your survey of 614, 258 said yes, okay. The rest of them, some of them said no, some of them, we don't know, that's fine. But this is our sample result. This is the result of the sample. Result of the survey. But this is our survey. Sample is 614 small business owners out of all of them. How many? I have no idea. What's the population size? I don't know. They didn't know. Why should I know? Very good. Just a quick definition. The definition of parameter and the definition of statistic. Definition of parameter. These are new terminologies. Definition of parameter. A parameter is numerical characteristics, the numbers that we find and assign to the population. Parameter start with P, population start with P. So parameters are for populations. The numerical characteristics or just the numbers, like the mean, like the variability. I'm going to talk about this later, that are assigned to the population are called population parameters. Definition of statistic. These are the numbers, numerical characteristics like the mean, variability that we assign to the sample. So statistic for sample. The numerical characteristics or numbers. After analysis of the data, the numbers like mean or variability that are assigned to a sample. So in chapter 1, we mainly talk about terminologies that we're going to eventually use throughout the course.